This is a demonstration of Terraform Cloud version control integration. Here, we'll demonstrate how pull request automation will allow us to test and examine configuration changes in a test environment before merging them back into a production infrastructure setup. When we first start to use version control integration, we need to configure our organization's settings. In the Organization's Settings tab, we need to add a specific VCS provider that we'll be using. When we add a VCS provider, we have several options, including GitHub, Bitbucket, and GitLab. Here, we will need to add a client ID and client secret that refers to the particular version control provider that we are using. This must be configured in the version control system. Once it is added, we will have a selection of VCS providers that allow us to connect to our version control system of choice. In my workspaces, notice that there is production infrastructure already existing. This infrastructure consists of a network with a Kubernetes cluster deployed to Google Cloud. Here, I've already applied the configuration to my production infrastructure. Let's say I want to add a backup subnet to this particular setup. However, I do not want to do this to my production infrastructure. Instead, I want to apply it to a test environment that is similar to production and examine if changes will affect any existing infrastructure. First, I'm going to start by branching my master configuration. Here, my configuration mimics production. I'll push this to my QA remote branch. Next, I'll set up a Terraform Cloud workspace pointing to QA. When I specify my Terraform Cloud workspace, I am using prefixes in order to allow me to select specific workspaces, but prefixed with an organization or specific tag. I'll initialize my new QA workspace using Terraform Workspace New QA. This will create a new QA workspace in Terraform Cloud. As you can see, it's prepended by our prefix tfcloud demo GCP. In my new workspace, I'll add a few settings. First, I want to ensure that I auto-imply for my QA environment. This is because it is a test environment, and I want more immediate feedback on whether or not my configurations have succeeded. Next, I'll specify the working directory, in this case, GCP. After I've applied my general settings, I can go to version control and configure it to point to my VCS provider, in this case, GitHub. Once I've connected to a repository, I am able to determine any remote branches that are currently existing. In this case, I want to point to the QA remote branch. Terraform Cloud does not automatically pre-populate variables. Instead, we must insert them with the UI or push them using the Terraform Cloud API. Using the Terraform Cloud API and some helper scripts, I'll create some new variables in my QA workspace. Notice that my cluster name becomes tfcloud demo GCP QA after the workspace. I also include my GCP credentials, which are masked as they are sensitive. Now that I've organized my variables and connected to my remote branch, I can queue a plan. After my plan is completed, I'll begin by creating a new backup subnet against this QA infrastructure. This will allow me to assess if the new subnet will impact any of my production infrastructure. I'll call my new subnet Backup. Next, I'll commit my changes to my QA branch. Then I can push it to my QA remote branch. After I've pushed to my remote branch, I should see a new run triggered in Terraform Cloud. As you can see here, the new run contains my commit message and my commit hash. As we've previously configured, this workspace will automatically apply successful plans. This way, I get fast feedback on whether or not my configuration was successful. When I'm ready, I can create a pull request to merge my changes back into master. When I create a pull request, this will trigger a Terraform Cloud check. It is checking the Terraform plan of my QA workspace. It will also trigger a Terraform plan on my current master branch. I can view this output to ensure that the configuration is what I expect. When my checks have completed, I can merge my pull request. This will trigger a new run in the production workspace. When my production changes have completed, I can remove the QA infrastructure, delete its workspace, and destroy the QA branch.